Good morning, dear student. In today's lecture, we will start our semester second of course CHG 190, in which we select the elective option B, that is organometallic and inorganic reaction mechanism. So, this section contain total three chapter. So, chapter first, let's discuss about only chapter first. Chapter first is your organometallic chemistry. Chapter first, it is our organometallic chemistry. So we are very much familiar with this organometallic chemistry since we study from it from TYBSC. So organometallic chemistry. So from this chapter we discuss some important points such as the organic ligands and their nomenclature. Organic ligands and their nomenclature. The first point from this chapter, that is organometallic chemistry, organic ligands and nomenclature. Second, the 18 electron rule, 18 electron rule and the counting of electron. Third one, third important point is that the ligand having extended pi system. So we discussed this point, that is ligand having extended pi system. So this is our first chapter, that is organometallic chemistry, in which we discuss the first point, that is organic ligands and their nomenclature. Then second, 18 electron rule and the counting of electron, ligand having extended pi system. Let us discuss some important points of this chapter. That is, the next point is the bonding between bonding between metal atom bonding between metal atom and organic pi system. And organic pi system, organic pi system, in which there is two type. One is linear pi system, and second one is cyclic pi system. Cyclic pi system. And the last important point of this chapter is that the spectral analysis and characterization of organometallic complexes. Spectral spectral analysis and characterization of organometallic complexes. Organometallic complexes by IR and NMR. IR and NMR spectroscopy. So these are the some important points of the chapter first, that is your organometallic chemistry. That is organic ligands and their nomenclature, 18 electron and the counting of electrons, a ligand having extended pi system, the bonding between metal atom and the organic pi system such as linear pi system and cyclic pi system, and the last one is spectral analysis and characterization of organometallic complexes by IR and NMR spectroscopy. Let us discuss the first important point of this chapter is that the organic ligands and their nomenclature. Organic ligands, organic ligands and their nomenclature and nomenclature. So we are very much familiar with this ligand and their name. So here we consider the ligand and their name. So the first one is, we are very much familiar with this ligand, that is CO ligand, that is carbonyl ligand. Its name is carbonyl. So we are very much familiar with this carbonyl. It is 2 electron donor. It is a neutral ligand. Then the second one is your this is your carbene. So we are very much familiar with this carbene. Then the next one, that is your C triple bond, that is your carbine. So these are the some organic ligands and their nomenclature. CO, that is carbonyl, then double bond C. Okay. For example, the R group is hydrogen, then it is carbene. Okay, and then the triple bond CH, it is considered as carbene. The next one, that is the next important ligand, that is your cyclopropenyl. This is your cyclopropenyl, that is your cyclo C3H3, means cyclo C3H3 positive. To maintain its aromaticity, it having a one positive charge. This is cyclopropenyl C3H3 positive. Then the next one is your cyclobutadiene. Cyclobutadiene is there. Then the next one is your, we are very much familiar with this. This is your cyclopentadienyl. Cyclopentadienyl. Cyclopentadienyl, cyclo C5H5. Okay. The next one is your, we are very much familiar with this, that is your benzene. So cyclopropenyl, cyclobutadiene, cyclopentadienyl, benzene, the ligands and their names. Let us discuss the next one, that is if you draw the structure like this, and the double bond is here, then it is 1 5 1 5. If you consider the numbering, this is 1 2 3 4 and 5. Then it is 1 5 cyclooctadiene. Cyclooctadiene 1 5. So there is a double bond at carbon number 1 and carbon number 5. So this 6 7 8, total 8 carbons is there, therefore it is octadiene, 1 5 cyclooctadiene. Then the next one is your ethylene. We are very much familiar with this ethylene. It is your neutral ligand because the donation of electron from the pi bonds. So ethylene. Then the next one is your CH triple bond CH, that is your acetylene. Ethylene, acetylene. Then the next one is your CR3, that is your alkyl substituent or alkyl group is there. And if this C double bond OR, then it is your acyl group is there. So these are the some examples of organic ligands and their nomenclature, that is carbonyl, then carbene, carbine, cyclopropenyl, cyclobutadiene, cyclopentadienyl, benzene, then ethylene, acetylene, alkyl, acyl is there. Then the next important point is that the corresponding formulae and names are designated according to this system as follows. So no doubt these are the some organic ligands and their nomenclature, but corresponding formulas. Some formulas and their names are designated according to this, according to this system as follows. That is the number of bonding position, then their formula, and then their name, and then their structure. So we are classified. Let us consider some example. That is the number of bonding position. The first column is number of bonding position. We are consider this is for cyclopentadiene. The number of bonding position, if it is 1, number of bonding position, if it is 1, then the formula, it is eta 5 eta 1 C5H5. What it indicates? The eta, it indicates the hapticity of the ligands, and the number of bonding position is 1, means not all the 5 carbons are attached to the metal atom, only one carbon is attached to the metal atom. So this is the classification. So if the number of bonding position is 1, the formula is eta 1 C5H1, it is only considered for cyclopentadiene. Then is then the nomenclature is monohaptocyclopentadienyl. This is your monohapto. So hapticity is 1, monohaptocyclopentadiene, cyclopentadienyl, monohaptocyclopentadienyl. So its hapticity is 1, means only one carbon is attached to the metals, and the number of bonding position is 1. If we see the structure, then it is like this: metal, like this. So this is your double bond is there. Okay, so only one carbon atom are attached to the metal atom, so its hapticity is 1, therefore it is considered as monohaptocyclopentadiene. If it is the number of bonding position is 3, then its formula is eta 3 C5H5. So its nomenclature is trihaptocyclopentadiene. It is trihaptocyclopentadienyl, and the structure, it indicates the 3 carbons atoms are attached. For example, if we see the structure, so only one double bond is remain, and these 3 carbon atoms are attached to the metal atom. So this is 1, 2nd, and 3rd. 3 carbons are attached to this metal atom. Its hapticity is 3, and therefore it is considered as trihaptocyclopentadienyl. So number of bonding position is 3, or the number of carbon atoms attached to the metal atom is 3. If it is 5, then its hapticity is eta 5 C5H5. Then it is considered as a pentahaptocyclopentadiene. So all carbons are attached to the metal atom, and we denote it is as like this. So it is denoted by symbol like this. It indicate all the 5 carbon atoms are attached to the metal atoms. So this is the classification. It is based on the number of bonding position in cyclopentadiene. So it is eta 1, eta 3, eta 5, depending on the number of carbons attached to the metal atom. Again, as in the case of other coordination compound, bridging ligands, which are very common in organometallic chemistry. So we are very much familiar with this bridging carbonyl. So carbonyl, it is mainly act as a bridging ligands. So the ligands, bridging ligands are very much common in organometallic chemistry, and they are designated by the prefix mu. Whenever there is a bridging ligand is there, any bridging ligand is there, then it is denoted by symbol mu, that is prefix mu, followed by subscript, indicate the number of metal atoms bridge. So followed by subscript. So bridging means it is denoted by symbol mu, and the subscript indicate the number of metal atoms are bridged. For example, let us consider the number of metal atom bridge, the number of metal atoms bridge, number of atoms bridge. If it is none, it is considered only carbonyl. Let us consider only carbonyl. None means this carbonyl, it is your terminal carbonyls, so they are not at bridging position, so it is only denoted as CO. If the number of atoms are bridge, okay, two metal atoms, okay, so the carbonyl ligand, it is in between two metal atom, so the number of metal atom bridge is 2, or the number of atoms bridge are 2. Then if the CO, it is bridge between two metal atom, then it is denoted by symbol mu. Mu means what? The ligand is bridge. So in this case, none CO is bridge, therefore it is terminal CO, it is indicate only CO. But if the carbonyl is present between two metal atoms and this is a bridging carbonyl, then it is indicated by mu, and the subscript 2 CO, subscript 2 CO, what it indicate? The carbonyl is bridging. So mu, the meaning of mu is the carbonyl is in bridging, means it is attached to two different metal atom, and the value of 2, that is subscript 2, indicate there is a two metal atom. So this is like this metal, this is C double bond O, this is the structure. So what it indicate? The carbonyl, mu stands for the bridging carbonyl, and 2 stands for the number of metal atoms. So there is a two metal atoms in which the carbonyl is bridge, therefore it is denoted by symbol mu2CO. If you consider the another one, that is if the number of atoms bridge, if it is 3, then it is denoted by symbol mu3CO. So what it indicates? The carbonyl is bridge and it is attached to three metal atom. So if you denoted by metal, this is your carbonyl, it is attached to metal, it is attached to metal. So the carbonyl is attached to three different metal atoms. So it is a bridging carbonyl and it is attached to three metal atom, therefore the symbol is mu3CO. So these are the some important points regarding to the ligands and their nomenclature. In the next lecture, we are very much interested in the counting of electrons. Generally, the two methods are used for counting of electron. One is ionic method, it is also known as oxidation state method, and the second is neutral electron method. So we will discuss the counting of electrons and the 18 electron rule in the next lecture. Thank you.